Hello, this is Team J, and now we are here to present our test data. So here you will see they have the same arrangement of the processes in a Gantt chart. It started with P1, then it ended with P4, and the table they have the same burst time, completion time, waiting time, and turnaround time. They also have the same total, which is the turnaround total time is 173 milliseconds, while total waiting time is 128 milliseconds. The average waiting time is 12.80 milliseconds, and the average turnaround time is 17.30 milliseconds. So here you will see P1 is the first one to arrive, so that the Q1 starts with P1, then followed by P10, which arrives at 1, and so on and so forth. So only P10 and P4 is processed in Q2 because they have a remaining time in Q1. Q1 only process 5 milliseconds, and P10 and P4 has a burst time of 15 and 6. So those burst time will deduct by 5 milliseconds because Q1 only process 5 milliseconds, and the rest will be processed in Q2. So here in Q2, we have 10 milliseconds, but P10 only remaining time is 1 millisecond. So it processes 1 millisecond in Q2. And in P4, the remaining time after the Q1 is 10. So since the Q2 has a 10 millisecond quantum time, all the remaining time in P4 processed in Q2, and there is no process here in Q2 because all the processes is done within Q1 and Q2.
So in the test data 2, we have 3 process ID, which is process 1 have 0 arrival time and 6 burst time, and process ID 2, which is 4 arrival time and have 1 burst time, and process ID 3 have arrival time of 8 and burst time of 10. Here in Gantt chart, we put process ID 1 into 0, 1, 2 because quantum time 1 has 3 milliseconds and process ID 1 have burst time of 6 minus 3. So the rest of burst time we will put it into quantum time 2 because in the quantum time 2 we have 5 milliseconds. So process ID 1 is 0, 1, 2, 3, 4, 5. Then in the we put process ID2 in the number 6 because process ID2 has burst time of 1. So quantum time 1 has 3 milliseconds and the burst time of process ID2, which is only 1, so we put it into quantum time 1. Then next is process ID3 have 10 burst time. First 3 of burst time we will put into quantum time 1 because quantum time 1 is only 3 milliseconds, so 8, 9, 10. Then the rest is 7 burst time, which is in the quantum time 2 has 5 milliseconds. So we put the process ID 3 into 11, 12, 13, 14, 15. And because of quantum time 2 is only 5 milliseconds, the process ID 3 is only have 2 burst time. So we put it into FCFS, which is 16, 17. So here in the code, as you can see, it is similar to the Gantt chart that we see in the Excel. And the total of waiting time is 2, is similar into the code here, 2 milliseconds, and the total turnaround time is 19, which is also same, 19 ms, and the average waiting time is 0.67 ms, also same, and average turnaround time, which is 6.33 ms, is also the same of in the code. So that's all.
So this is the test data tree. So there are 5 processes in test data. In P1, it has arrival time of 0 and burst time of 15. In the P2, there is arrival time of 5 and burst time of 3. In P3, there is arrival time of 1 and burst time of 10. Next is the P4, which has arrival time of 4 and burst time of 6. And lastly, the P5, which has arrival time of 1 and burst time of 1. And for the quantum 2, quantum 1 is equals to 3 milliseconds, and for the quantum 2 is equals to 5 milliseconds. So the computed and code Gantt chart has the same sequence of the processes. So the P1 has 0 to 3, P3 is from 3 to 6, P5 is from 6 to 7, P4 is from 7 to 10, P2 is from 10 to 13, and so on and so forth. So between the two, they have the same total waiting time, which is 68 milliseconds, and they have the same total turnaround time, which is 103 milliseconds. So lastly, they have average waiting time, which is 13.60 milliseconds, and the average turnaround time, which is 20.60 milliseconds.